This is the teaching flume, and the total length is about 5 meters. And there is this water tank, and it also provides the water circulation in this flume. And we can, there's this rotate wheel, and we can adjust the slope of this flume. And here, because we just turn it at the beginning, the water tank is set here, but because of the space limitation, people cannot go there to look at the volumetric meter. It's here, so we decided to turn it 180 degree, so put the tank at here. And but the consequence is that we cannot see the scale. We have to go inside and see the scale from here. Here's the scale, and
that just shows length measurements, right, along the flume.
And
someday we'll get
today,
another piece of measuring tape.
I'm going to show you the first exercise using this flume. It's characteristics of flow over a sharp crested over short weir. It's this one. So at the beginning, we should measure the width and the height. I think that only the width should be okay of this weir module, and we can next step can put it here inside.
Take that.
And to prevent a leaking, somewhere it's not so tight with the glass here, you can use plastic sign. Use this to block any leaking. Today I won't do that, and I'll use this. There's a hook here, and you can put it out. The hook from this gland is here, down here, and I just take it out and insert into this gland from above, and I'll put it down. Okay, so use
that
this,
will hold it in place?
to hold it at the place, and then this is the hook gauge, and it can measure the level of the water surface, the height of the water surface. And now I just start this circulation. Okay, I use this valve to increase or decrease the flow rate. You can read it here, directly from here. Okay.
We hear water flowing now. So there's water down in that reservoir. We're now pumping it through this tubing to the other end of the flume. And we can see it start to
keep at 0.
Start to flow.
Keep it flat. Okay. Yeah.
So it's flowing and encountering this weir. Tiny bit of leakage coming through.
Yeah. So that means every time you run this exercise, you need to use the plastic sign.
And as we will see, the open end of the flume here, when water comes through, will just empty down into the reservoir for recirculation.
So we just according to the instruction, we need to measure the
Got our first little bit of spill water coming, draining down into the reservoir.
Water just come over this weir, and there's a net. It's called net. It's clean to the wall of this weir. And later on, we need to get rid of this net, and we can use a to merge these tubing inside the water body. Yeah, you can see it's clean to the wall. Then this side is merged into the water, and there's a curve of clean to the wall. So we need to use a tube link to here. Okay. And I just blow air in. Let me increase the now you can see the green. It is called nab, as I remembered here, and I will blow air in. We'll make a cavity.
So there's a whole airspace in there now.
Okay, so now we can start measuring. Use this hook gauge and let the end just contact its reflection here. You see so it's the accurate measurement. Yeah. From this angle, you can see it touches its projection in the water.
Very nice.
Yep. And that's the way measure the height of the water surface.
So how do we read this
From
scale?
here. Yeah, from here.
So this is calibrated so that the number
Yes, the zero, it's
measures the
millimeter, I think.
depth from the base to the water, on top of the water column.
Yep.
And so we should read this as 140.5 millimeters, is that?
Read from the zero, I think.
Oh, read from
Yeah.
the zero.
Yeah, it's a 136 something.
Uh-huh.
Yep. Yeah, I forgot to do the measurements from here. So we need to get the height of this part. Yeah, we also use this, just move this. And use this tip, touch the tip of the weir and get the length of this part. So using the total height to deduct this part. So that's the YC, I think. It's here. YC.
YC, yeah.
So
Height of the-
yeah, height about, and we can do it. We can record it in this table and do the calculation. We get the breadth of the weir and the height of the weir. We got the YC is the height, and Q should be the flow rate or volumetric rate. And we do calculations. We can make a plot. Okay, so the procedure is here to increase the Y0. Should be this one, this part. Increase the Y0 by 0.01 meter a step. Yeah, just increase the flow rate to increase the height of the water surface by 0.01 meter per step, and measure every step's height and the flow rate, and do calculations and to make a plot. And finally, we need to compute the discharge coefficient CD using this equation. Yeah, so that's the objective of this experiment. So students can just do it using the, I think there's a software. There's a software, you can do it on your laptop to do the calculation, automatically calculation, to get the CD and make a plot. So that's the objective of this sharp crested weir module experiment.
Right, so and that's one of several experiments that came
we have,
prepackaged with
yeah,
this
we have-
apparatus.
This is adjustable underwear shot, so can adjust the height of this wear. And we also have let's see, different shape of the wear. This is called crump wear, and this is broad crested wear. You can also put it into here, into the flume. And there's another one. This is Venturi assembly. You put it here to make the flume, get thinner, and inside here the flow rate will be much more, increased. So we also have this artificial roughened bed, just inside, to simulate the nature, like a river, the river bed. There are other.
But due to an ordering error, mostly by me, we don't have enough of those to cover the whole 5 meters of the flume. So we'll see. And then the other big piece of equipment we have
This one
is actually a wave generator.
it's too heavy.
Which-
I can't. Yeah,
Right,
I
we
can't
haven't
move it, so I
really
didn't
started to
try.
work with yet. But
Yeah.
this, in principle, this will sit on top of the flume, and there's a piston that moves that will create a wavefront that will propagate along the flume. And, that should be interesting. So I'm gonna make a mess here. Let's take this Venturi gate thing. Let's see. You want to put it in?
I think it should be like this.
Yeah.
But this, I think you need.
Will they hold them, or
No,
are those
no.
designed to be attached with the
Maybe you need
plasticine? Or?
plasticine to attach it.
Well, you will kindly hold it for us for the moment. Let's see what it does to the flow.
Yeah, you can see here the flow rate just increased drastically.
Is that have any effect on our on the height of our? Maybe, maybe not. Let's put one more toy in there. Take this guy.
Yeah, you also need a hook inside from here.
Right, so we could put a hook in to really lock it into place, but all right. So just for the purpose of this video, for the sort of cleanup when the experiment is done, if we, what do we need to do? We just turn it off and let it drain?
Yeah, it will drain. You know, we can just increase a little, increase the load, the little, and the water will all flow into the tank.
So the power switch here will turn off the pump. It's just draining. We can make it drain much faster if we pull this hook out.
No. You
Nope.
need to, because there's a hole
there's
there.
a hole.
Yeah.
Yeah,
So
I
then
was like, I think water's gonna come up the bottom.
I was trying to make a dramatic demonstration, but
Which I'm
so
telling
so
people
so
are
what
not-
would be the clean way to disassemble this then? Just
Just
wait?
take it out. Yeah, wait until the water all gone, and you can take it out.
Okay, so now we're just depending on the little bit of leakage to
Yeah,
let it
just
drain
take a
itself.
little. You can increase the load.
Yeah, you could lift it a little bit.
Yeah, lift it.
There we go. All right, that's this.
Don't pull it out, but
Thankfully, we have the smart people here to tell us how to do this. And just for reference for the video, if there is a big spill, it's just water, but over here in the lab, across the room, there is a floor drain, which is there for that purpose. So if there's water on the floor, that's where it goes. And if we need to, empty the reservoir,
Just move it there and can drain the tank.
I think often this reservoir will just be full of water, but if we need to change the water, right, it's on wheels. We can just move it and open the drain valve at the bottom,
so the
which
idea
is
is
here.
not to put dye in there because then you would dye the water.
I think there are some experiments where you're dyeing the water, and in that case, you would need to drain the tank and probably flush it with some clean water. Okay, great. That's the end of our demo.